All right, let's learn how to do radians and degrees. So you already know what degrees are when you have a circle. That's a terrible circle, but whatever. That circle is 360 degrees. But if you have in radians the same circle, that's 2 pi radians. So radians don't actually have a unit symbol. Sometimes you'll see it as rad if they need to specify that it's in radians. But when you're talking about angle measures and you don't have a degree symbol, that means that it's in radians. Whereas if you do have a degree symbol, obviously that's in degrees. So if we want to think about conversions, 2 pi radians, I'm going to use that just so you know that it's not pi because, well, it'll make sense in a minute. 2 pi radians is equal to 360 degrees. Again, you don't have an actual unit symbol for radians, but I'm writing radians here so you know that you're talking about a unit measure and not the value of 2 pi itself, because obviously 3.14 times 2 is not equal to 360. So if you divide out that 2, pi radians is equal to 180 degrees. This is enough that we need for conversion. You don't really need to have more. You don't need to divide by pi because that would just be tedious and it doesn't really help because you would have to multiply it back in anyway. So we'll use this to convert. All right, so let's get rid of these circles. Let's do it over here. 360 degrees and 2 pi. Okay, so let's work on conversion. Let's do 90 degrees. Convert to radians. So if you have 90 degrees, let's do that in a different color. 90 degrees. And you want to convert that to radians, well, you would have to divide by 180 because you have the degrees here. Let's do, our ratios are going to be either pi over 180. Let's switch that back to black because we don't need to erase that part, but our ratios are either pi over 180 in order to convert to radians, or 180, let's do the degree symbol, 180 over pi if you want to convert to degrees. So it's whatever's on top. When you're converting to radians, you have the radians on top. When you're converting to degrees, you have degrees on top. So using that, we can just go ahead in with the ratio. Pi, switch back to our work color, pi over 180 degrees. So 90 divided by 180 is equal to 1/2 because it's 9 over 18. 9 to 18 is 1/2. So you have 1/2 times pi. So you have pi on top. So 1/2 times pi is pi over 2. So your answer here is pi over 2. So pi over 2 radians, no unit symbol, is equal to 90 degrees. All right, what if you have 270 degrees? Let's do that in black. 270 degrees, 2 radians. Well, if you have 270 degrees and you want to convert to radians, you use the radians ratio, which is pi over 180 degrees. 270 divided by 180 is 3/2, 3 over 2, because again 27 over 18, you can get rid of 9 from both of those and you get 3 over 2. 3 over 2 times our pi is 3 pi over 2. So your answer here is 3 pi over 2, which means that 3 pi over 2 is equal to 270 degrees. Now, if you wanted to draw these out, you have a circle here. Now, let's do a circle. Okay, that was worse, but a circle here. You split it by, let's have it on a coordinate plane, right? So this is 0, 0. This here is 1, 0, negative 1, 0, 0, 1, 0, negative 1. So if you had 90 degrees, that's right here. Let's do that in a different color. Oh, crap. That's right here. That's your 90 degrees. But that's also pi over 2. So if you went here, that's 2 pi over 2, which is just pi. And if you went here, then that's 3 pi over 2, which is a distance of 1 pi over 2 from pi to 2. If you went all the way around here, that's 4 pi over 2, which is the same thing as 2 pi. And hey, that's our radian measure for a circle. You can do the same thing with 270, where you have a circle, and on the coordinate plane, our center is the origin, and our 270 degrees will fall right here. We just did, that's 3 pi over 2, 270 degrees. It's really helpful when you're solving for circle to convert to either, especially when you're doing math with radians, but you have it in degrees. So let's get rid of all of this. Let's do a couple more practice problems. Let's do one more degree problem, and then we'll switch to converting from radians. So if you have 300 degrees, that should be in black. 300 degrees. You want to convert that to radians. Let's get rid of our ratios here so then you can kind of do it yourself. Let's get rid of all of this actually. See how much you remember. But if you have 300, well, our ratio, in order to have radians, you need to have pi on top and 180 on the bottom. 300 divided by 180 is equal to 5 over 3. So you have 30 over 18. You can divide out the 6 from there, and then you get 5 over 3. So 5 over 3 times, I should have done this in a different color. Too late. 5 over 3 times pi is 5 pi over 3. So this answer is 5 pi over 3. So that means 300 degrees is equal to 5 pi over 3 radians. Okay, let's do one radians. Let's convert pi over 6 to degrees. If you get a question that's just like that gives you a value and tells you to convert it, if it doesn't have a degree symbol, it's in radians. You have to convert that to degrees. And if you have a degree symbol, then you need to convert it to radians because it's in degrees. I'm just writing 2 degrees here, so then it's easy to see if you want to go back and see what's going on. So our ratio for radians, you actually have radians on the bottom because you're converting to degrees, so you have the 180 on top and radians on the bottom. This is a little bit easier because these pi's cancel out, so you get 180 degrees divided by 6. That equals 30 degrees. So 30 degrees is equal to pi over 6 radians. A lot of these are common that you'll see when you're solving inside of a circle, when you're solving for certain angles, and especially with the unit circle, which I'm sure you probably already know about by now, but they're really helpful. All right, let's do 2 more radian problems. 7 pi over 4, it's in radians, so let's convert to degrees. So 7 pi over 4 times, our ratio is 180 degrees over pi. These pi's cancel out, so you get 7 over 4 times 180. And you can probably plug that into the calculator and figure out what it is, but considering that I already know the answer to that one, it's 315 degrees. Now it's good to remember that anytime you have a fraction for radians that has a 4, it's over 4, it's fourth, then your degrees will always end in 5. It's just a given rule. There are patterns obviously with pi over 3 and pi over 6, which you'll see in the unit circle, but the pi over 4 ones are the easiest to remember. Now 7 pi over 4, if you drew that on the unit circle, with the origin as our intersecting point, you get it right here. So that is 7 pi over 4, but it's also 315 degrees. So if you wanted to solve for the distance from the x-axis here to that 315 degrees, you would get 45 degrees. 45 degrees then is equal to pi over 4. That's with coterminal angles, which we'll get into in a different video. But that's our answer for this one. Now if you have, let's say, 8 pi over 3, 2 degrees. Go back to the galaxy pen, even though I haven't been for the past couple. But you have 8 pi over 3. A ratio you need to convert to degrees, so you have 180 on top, pi on the bottom. Those pi's cancel out, and you get 8 over 3 times 180 degrees. So the answer to that would be 480 degrees. Wait, that's bigger than 360, isn't it? So when that is because 2 pi is 6 pi over 3. 8 pi over 3 is bigger than 2 pi over 3. So that is going to give you a value that's bigger than 360. So essentially what it's doing is it's starting from here, going all the way around and then some. So if you were solving for the angle that's the distance from this x-axis to the angle that you have, you would get 2 pi over 3. Oh, sorry. This should be here. You have pi over 3 here, you have 2 pi over 3 here. 8 pi over 3. It's the same thing as 480 degrees. You're going all the way around and then some. So if you were solving the distance from the x-axis right here, then you would get pi over 3. If you were solving from the x-axis on the other side, here, you would get 2 pi over 3. So there's all kinds of math going into where it is on the circle. But if you want to solve for what degree is equivalent to that, that's 480 minus 360 degrees, because that's a full circle. That would be equal to 120 degrees. So if it was just solving, it was just asking you to convert 8 pi over 3. So 480 is the answer, but 480 degrees will end up at the same place on the circle as 120 degrees, which would end up at the same place on the circle as 2 pi over 3. So all 4 of these angle measures end up at the same place. But that's it. That's what radians are, what degrees are. Hopefully you already knew what degrees were at this point, and that's how you convert them. So just remember that if 2 pi radians is equal to 360 degrees, then pi radians is equal to 180 degrees. So when you're converting, let's try this one. When you're converting from degrees to radians, then that sucks actually. Sorry about that. You have your radians on top for pi over 180 degrees, and when you're converting to degrees, you have 180 on top, 180 degrees on top, and you have your radians underneath as pi. And that's pretty much all you need to know. Hope that helps.